All right, everybody, we're going to go through this last practice question. So as you looked on the website and saw, you could either try to do this on your own without watching the video first, which would be recommended, but if you feel like you couldn't do that, you can watch the video and solve it as we're going through the video. So this problem is another chi-squared goodness of fit test because we're seeing if the distribution of people with these different blood types is affected by their personality. So we have the standard proportions down here, and then we observe values from our sample of 150 from the arts minors, majors and minors in arts, who we assume are more creative than, I guess, the rest of the population. So part A is asking us for our null and alternative hypotheses. So your null hypothesis is going to be, again, a statement of no difference. So that means that if there's no difference, the personality is not going to affect the distribution of blood types. So we're going to expect that from our sample 150 that the proportions will be the same that are listed right here, given to us in the problem. So that's what I put down for our null hypothesis. And again, you use this little shorthand so you can write out, abbreviate the different blood types. So we expect that there be no difference, so then that means the proportion of type A blood would be 42%, type B blood would be 10%, type AB blood would be 4%, and type O blood would be 44%. And then your alternative hypothesis would be at least two proportions are different. Again, you can watch that last video for why it's 2 and not all or 1. So we say at least two proportions are different than that. That's our alternative hypothesis. All right, now let's go down to our next one, which is our expected accounts, expected values, expected numbers. Again, different names for the same thing. So this is what we would expect to get from our sample if there really wasn't a change and that these probabilities, that these proportions that we listed for our null hypothesis were the same. So we take our sample size, which they gave us as 150, and then we times it by our expected proportions. So we get 150 times 0.42, which gives us 63, 150 times 0.10, which gives us 15, 150 times 0.04, which gives us 6, and 150 times 0.44, which gives us 66. Again, we get those numbers by sample size, times it by the no difference proportions that are listed in our null hypothesis right here. And those are going to be our expected values, which, as you saw in the last video, we have to use that for our conditions and our calculation for our p-value. So for this one, our conditions, random, it tells us a simple random sample. 10% rule, we know there's definitely more than 1,500 creative adults in the U.S. And then all of our expected values are greater than 5. You can see for the type AB blood, started getting pretty close to that 5, but it's still above it, so it checks out. So all three of our conditions check out. So we move on to the third part of our significance test, calculating the p-value. We use our formula that we learned in the last video, observed value minus expected value squared divided by expected value. So for type A blood, we have an observed value of 50 minus our expected value of 63, square it, divided by 63. For our type AB blood, we had observed value of 23, expected value of 15. You saw right there. Type AB blood, observed value of 10, and expected value of 6. And then for type O blood, we had observed value of 67, expected value of 66. Again, probably the easiest way for you, the most accurate way for you to calculate this is just to do each one of these individually in your calculator. because it's going to be hard to put that in the calculator. If you mess up one thing, you're going to have to go back and change it. So I just recommend doing those individually and then adding them up at the end, which gives us a chi-squared value of 9.6311. Remember, our degrees of freedom is going to be 3 because we take our number of categories minus 1 to get our degrees of freedom. So we do 4 minus 1, which gives us degrees of freedom of 3. Then we convert that p-value to p-value using chi-squared CDF in your calculator, and that gives us a p-value of 0.0220. So for our analysts, we say that since our p-value is 0.0220, we have statistically significant evidence to reject the null hypothesis. All right, and we do that because it's below our significance level of 0.05. We have evidence that the personality type can affect blood type. Okay, so we have evidence because we have such a low probability value that that personality type does change the expected values for the blood types. And just like the other one for part E, if we made an error, it'd be a type 1 error because we rejected the null hypothesis, and then type 1 errors where you reject the null hypothesis, but it actually is true. So that is how you do those problems. If you're having trouble with the summative, make sure that you go back and look at these videos for some extra help.